Welcome to Chapter 6, everybody. And in Chapter 6, we're going to be focusing on applications of the integral. And so, in order to be able to work with these applications, we're not necessarily going to spend so much time evaluating the integrals as we have in Chapters 4 and 5. And so we're going to use the calculator now to be able to evaluate things. Really we're going to be looking at how we're setting up the integrals and what we can use these integrals for. And so today is all about using the calculator, the TI calculator, to solve these. And so here we have an indefinite integral in our form from a to b of a function of x with respect to x. And in the TI calculator there's a function called fnint, which is the integral function. And what we do here is we type this in, and then we enter our function f of x, and we put a comma, and then we put which variable we're going to integrate with respect to. This is x, and then comma, and then we put our limits of integration a, comma, b, and when we hit enter, it goes ahead and gives us an approximation for that definite integral. Now, function integral is found under math, and it's number 9. Okay, so we're going to take a look at it through two different calculators here, the TI-84 plus. Okay, so if we go into math, and if we scroll all the way down, you're going to see fnint. You can also see it's the number 9, so you could just push 9, and there we go. Now in my calculator it's kind of set up more visually the way we're used to seeing it, and so we put our limits of integration here and here, we put our function right here, and then the variable that we're integrating with respect to. So let's just do our first example here. So we're going to put 1 to 2. Our function is x squared minus 3. And this is with respect to x. Then we'll hit enter. And there we see negative 0.6666 repeating. Alright. Now we might see it another way in a different calculator. So if you're just with the TI-83 or it doesn't have the special setup, you're still going to push math and then number 9. And there you have fnint. And you do the same thing where you just type in x squared minus 3, so there's your function, and then comma, this is going to be with respect to x, and then comma, we want 1, comma 2. Okay, so it's a little bit more to try to remember when you're using this calculator as opposed to this one right here. I'm going to be using this one because I like how look, it's all pretty. So let's try our next one. Okay, so it's math 9. We're going to go from 1 to 4. This is going to be 3 square root of x. And I'm going to just say with respect to x. So even though the problem says t's and dt's, you can just use x and dx, and that'll work just fine. Here we get 14. So you can see this is going to be a huge time saver when we're working with these applications. Alright, in our next example, letter C here, you can see we have a trig function. And so we have to make sure that we are in radian mode. So just check your mode real quick, that it says radian. We're good to go. Okay, so again, math, 9, so we don't have to scroll all the way down. And then 0 to 3 divided by 4 and pi. We should be fine there. And then sine of x with respect to x. And we'll hit enter. We get 1.707. Now we're always going to try to go out 3 decimal points, and this is, of course, an approximation. So now I'm going to give you a chance to try D through F on your own. We'll go ahead and pause this, and then we'll come back together in a second to check your work. Alright, next we're going to take a look at how we can also find the definite integral using our graphing functions. So the example says, sketch the graph of the function and shade in the region found by the definite integral. Also evaluate the definite integral. So here, what we want to do is work in our y equals. Okay, we're going to go ahead and just put our function f of x into our y equals. So here we're going to put 2 plus x. And then we're going to go ahead and plot this. We can kind of see here where we want to go. And you could probably graph this on your own. So the y-intercept is at 2, and we have a slope of 1. And our calculator sketch looks pretty good right there. Now, you can see that this integral is going to go from 0 to 2. And so we have x equals 0 here and x equals 2 here. And we want to shade the area that is our definite integral. Okay, for the calculator, we can also evaluate this right here. So we want to go second, calc, and then we want the integral of f of x dx. So we're just going to push 7. Now it asks us for our lower limit, and you can see which function we're on right here. So you can do multiple functions at the same time. So the lower limit in this example is 0, so we can just type 0 and then hit enter, and you can see that it's marked it right here. And then it's asking for the upper limit. So the upper limit is 2. So we'll push 2 and hit enter, and you can see there it goes ahead and graphs the integral for you, and you can see it also puts the answer. The integral of f of x dx equals 6. So we know this is 6 right here. Alright, go ahead and give this a try on your own with example B. Alright, let's come back and take a look here. You should have gotten 6.6, and here is the sketch that I made. You can see the y-intercept is at 4. This is negative, so it's pointing down, and then it's just our x squared, so we get this here. We have the integral from -1 to 3 shaded right here, and here is the calculator, and that looks pretty close to the same with our integral right here. So that's it for using our calculators, and thanks for listening.